To lesson 2.5, the quotient rule. It is similar to the product rule in the terms of the top. See how the top has kind of the product rule set up, but instead of a plus, it's a what? A minus. And the other thing you have to understand is the bottom is the second thing squared. Now this is how you want to say it, okay? And this is the pattern that I get used to saying. I would put this somewhere. Okay, how you say this is low, D high. So low derivative of the top. So low derivative of the high one. So low derivative of the high. This is our low, this is our high. Okay, minus high derivative of the low. All over low squared. It's kind of the best way to say it. Low D high D low, all over low squared. That's where you get used to saying it. I've said it a million times in my calc career, so you'll probably say it as well. Okay, and again, it can be proved when we set up and do all the f of a plus h's and stuff, and you'll just see that they cancel out and it works out. I'll save your time with that. Any questions on just the quotient rule itself? Again, it's a rule. Okay, so on this one, does order matter? Absolutely, order matters. So it is important that you go low D high first. Okay, so this is important because of the minus sign, right? You can't switch around a minus sign. Okay, so it's important that you have low D high first. Okay, good. All right, so let's go to, then they have an 11/8 notation. All that is just with a d over dx deal. So you have low, so you don't have to write this if you don't want to, but it's low, and then this right here is d high, and then you have high, d low, low squared. Okay, remember d over dx just means derivative with respect to x. Okay, so you're still taking the derivative. Well, because we're going to be given a fraction. This quotient rule is for having, good question, you'll be getting something like this. So your high's there, your low's there. Yep. Okay. And let's get to an example here. So I'll do this one first, and the second one we'll let you guys try. So here is your high. Here's your low. So we want to go low, D high. So derivative of high is 2x plus 2 minus high D low derivative of the low is 3x squared. All over the low squared. So now it's just a simplification game. Don't FOIL or do the bottom out. Okay, wait until you see what the top is, because I don't want you to have to do that if you can't do anything with it. Okay, so FOIL this out. 2x4 2x3 plus 2x plus 2. That's a lot of 2's. Okay. Then we'll distribute this, and I'm going to distribute to here, and then it's going to get hit with a negative. Okay. 3x squared times x2 is x4 minus 3x4. Okay. And I'm going to do here and then hit the negative. So that's going to be 6x3 negative. And then a negative times a negative is a positive 9x squared. So that's what my top is going to be. So let's go ahead and simplify that. I have a 2x4, a negative 3x4, so I get a negative x4. Got a 2x3, negative 6x3, so negative 4x3. So I got these done. And there is no other x squared, so just a plus 9x squared plus 2x plus 2. And you can see right here there's really not much I can do further, so I will just leave it just like this, and this is your answer for now. But this still is, let's not forget, this still is f prime of x. So if you wanted to evaluate a point, you still could plug a point in. You still could plug like we did in the beginning. I could still plug a 1 in if I wanted. Right, just messy. Still represents the tangent slope. Still the derivative. Okay? All right, I'll let you guys try example 2. This is our last example already. As I said, today's very short. Okay, so go ahead and try this one. See what you can get. I will pause the video and start here. Okay, so low d high. What's the derivative of root x? We know that by now. 1 over 2 root x, right? Yep. Okay, minus high d low. Through low is just 2. All over low squared. Okay. What do we want to do now? Right, and this is the kind of game that you're going to have to do a lot in this class, so you need to get good at this. What I mean by that is that I essentially put this on top, right? So I'm going to have 1 plus 2x over 2 root x. So since I have this, what do I think I want this to be then? I want it to be over 2 root x as well. So I need to go, and you'll see what happens. I'm going to times 2 root x, the top and bottom, to put those together. And that's going to give me, what's these multiplied? 4x. So that's kind of nice. It gets rid of the radical for us up there. So we have minus 4x over 2 root x now. All we're trying to do, if you're trying to catch up, we're trying to get a common denominator of 2 root x between these two. So now I can put these together. 2 minus 4x is negative 2x. So I have 1 minus 2x over 2 root x over 1 plus 2x squared. What can I do from here? What's my fraction rules here? Difference of squares on the bottom. It's a plus though. Like, what do you mean? Yeah. All I'm asking is what goes where when I want to make this one fraction. So what goes where? Right, the bottom just goes to the bottom right here. So your final answer I just switched it on accident, not on purpose. That's the derivative. Questions, concerns? What's up?
I did it like a different way. I did instead of 1 over 2 root x, I did like x to the power 1/2.
Okay, so you changed this to up here to x to the power 1/2? Okay, so right, so I can look at it, but what you'd want to do there is, so yeah, so you move this up and made it x to the negative 1/2, and then you can't move the 2 up though. Right. Oh, you didn't move it up though?
Instead of using x